If you look at how much computational power something like AWS or Azure Microsoft, if you look at how much they have, it sounds impressive, and I'm not saying it isn't, but when you compare it to the idle amount of computation that exists in all the phones and all the laptops and all the desktops, it pales in comparison. So with this kind of software, you can unlock this decentralized AWS, so to speak, that also takes into account the edge. And then, of course, your laptop, when it's idle, you can actually make money of it.
Welcome to the Hacker Noon podcast. I'm your host, Trent Lipinski. In this episode, I interviewed David Sønstebø. He's one of the founders of IOTA, and in this episode, we discuss distributed ledger technology, edge computing, and what's happening in crypto today. He's also going to be appearing at Paris Blockchain Week in the middle of April, so you can catch him there. And please stay tuned for the rest of this episode. It's amazing.
This episode of Hacker Noon is sponsored by DigitalOcean. Join a community of over 3.5 million developers learning how to build and scale high-performance web apps on the simplest cloud platform. With a flat pay-as-you-go pricing structure and monthly caps across all global data centers, DigitalOcean makes it easy to get the computer resources you need without the billing surprises you get from other cloud providers. Discover why developers love DigitalOcean and get started with a free $100 credit at do.co/hackernoon. Full-stack developer Austin Pocus.
We're using it to host a discourse site. So basically they give us a machine and we run a Dockerized instance of Discourse on there. Gets a few clicks and Discourse is ready to rock. With DigitalOcean, they have a marketplace where you just click, I want Discourse, you provision a droplet, and you're good to go.
Welcome to the podcast. I'm here with David. Hey, David, tell us a bit about who you are and what you're working on.
Yeah, thanks for having me. So I'm David from Oslo, Norway. I've been in the distributed ledger space, blockchain space since 2012. Got into it really from my interest in something called extropy, which is kind of how to use technology to better mankind. That is something I got really into when I was around 15 years old. I read Nick Boström. I'm not sure if you've heard of him. He's the guy that kind of pioneered this worry about superficial artificial intelligence, like this. No, I mean super artificial intelligence that can kind of take over the entire universe if it runs amok. And I was really intrigued by that concept, so I really dug deep into that community. And this is where Wei Dai and Hal Finney and all of those legends hung around. Of course, at the time, I had no clue that they would be pivotal people in my future. This was back in 2004, 2005. But that kind of brought me into the community. And so I heard about Bitcoin over and over and over again. And at first I just dismissed it because it was kind of like, we're going to tear down the government and the legacy system. And I was just like, I'm not really interested in that right now. I'm more interested in how can this technology actually be used to leverage something good for mankind. But this is where I was introduced to blockchain and the Bitcoin white paper. So I read it. And at first, again, it was like, okay, internet money, that certainly has a future. But due to the connotations of that hardcore libertarian early following, I just didn't, it wasn't that mentally stimulating for me. But when I started thinking about the aspect of having an immutable ledger, I got really interested in how that could secure data. And also how it could incentivize decentralized systems like machines that has nothing to do with us as humans directly, but indirectly. So this kind of stuck in my head, and I got involved in the blockchain space very actively in 2012. Then in 2013, I met my co-founders, Sergey Vancheglo, Dominik Schiner, and Sergey Popov. We all met in this project called NXT back in 2013. NXT was the first proof of stake, like pure proof of stake protocol in the blockchain space. And here we also did a lot of experimentation with voting, like decentralized voting, decentralized asset management, and so on and so forth. But at the end of the day, it was really just an experiment, even though it ended up being like worth hundreds of millions of dollars. But for us, that it just wasn't interesting. Like crypto trading and all of that is just boring to me. But then in 2014, me and Sergey Vancheglo, we started thinking about distributed computing, which kind of tied back into what originally got me into the space. And here, of course, when you start thinking about the edge of the network, where there are billions and billions and billions of devices, you need a mechanism for these devices to be autonomous. They need to be able to transact in order to presume kind of this prosumer-consumer model and have this kind of identity. And when you start thinking about the extraordinary amounts of data that will be generated and how there will be autonomous decisions based on it, you really need to make sure that that data is secured. And here the immutability of a distributed ledger came in. But even though we had this background in blockchain, we knew that blockchain could not really scale to accommodate it. So that is why we started tinkering with the directed acyclic graph approach. We actually built on some earlier concepts by Sergey Popov, one of our co-founders, who had started tinkering with this back in early 2014. So we took that as a template and then evolved it, ran hundreds of simulations and calculations and all that, and ended up with the Tangle. And that was kind of the birth of the IOTA project. And in the beginning, it was squarely focused on solving this one thing of like the Internet of Things, enabling the Internet of Things to be secure and having devices interact and share technological resources like computation, storage, bandwidth, etc. So with this template in mind, we created IOTA project, and unlike most crypto projects, we did not want it to be focused on speculation. Mm-hmm. We were notoriously against speculation. I remember when we even did the crowd fund, I would regularly tell speculators, do not dare to put money into this. I do not want you in my community. Because I really wanted the genesis of IOTA to be focused on the technology. Like, let's make something legitimate here. So we took another unorthodox decision and chose to set up a non-profit foundation in Germany, which back in 2015-16 was kind of preposterous because you can imagine, like, even today, banks are quite reluctant to even set up an account with anyone that holds crypto. But back then it was like, oh, no, this is just drug dealing and money laundering and all of that crazy shit. But we did it because we had this vision in mind that if we are going to create a genuine global standard, if we're going to get accepted by this massive traditional industry of automotive and smart manufacturing, et cetera, we need that credibility. We need to be able to put ourselves through the regulatory, the regulatory machinery. And that's what we did. That's exactly what we did. So after a year of struggling, a lot of lawyer fees and a lot of back and forths, we got approval, and we were the first nonprofit in Germany completely funded by cryptocurrency. So that was a major achievement for us. And since then, we've been, just building and building and building.
Awesome. So I've got so many questions because I want to definitely dive into the Tangle. In 2017, during the whole crypto heyday, that's when I first got introduced to it. And I love the fact that you guys actually had code written. I could actually go download it. Your equations were in your white paper. It just felt more tangible and real than like 95% of the other projects that I was looking at that had no code. You couldn't download their wallets yet. Their white papers were kind of vague. And didn't give you the exact equations. Can you talk a little bit about the Tangle and how it differentiates from a traditional blockchain?
Yeah, for sure. So the best way that I tend to explain it, just as basic as possible, is to think of a blockchain as a very limited one-dimensional ledger, because you have a block and you wait for the transactions to go in. You're essentially bidding for your position in the block, which is the fee that you pay to the miners to prioritize your transaction over others. So you have this very rigid, linear block after block after block architecture. And of course, that's automatically a bottleneck because there's a limit to how many transactions fits into each block. And so there you have the bottleneck already. And you also, as soon as they get any sort of adoption happens, you end up with high fees because it becomes this bidding war of supply and demand. Whereas what the Tangle does is kind of parallelize it. So we go multi-dimensional, you could say. Instead of having this one-dimensional chain, we have anyone can issue a transaction, and that validates two previous transactions in the network. So you grow this DAG, this directed acyclic graph, where everyone that issues a transaction validates other transactions in the network, and you can see how that builds up this multi-dimensional ledger. And that gets rid of those bottlenecks because there is no blocks that you're confined to, so there is no hard limit on how many transactions can go through the network per second. And that also eliminates the need for fees, because my incentive for validating your transaction and some other transaction is the fact that I get my own transaction submitted to the network. So you have instead, we kind of completely flipped it. So now validation is an intrinsic property of utilizing the network rather than this kind of ad hoc. I consider blockchain a good prototype, but I just don't take it seriously as a self-evolving ledger, because you have these oligopoly mining pools that just control everything, and it just seems very ad hoc. So in contrast, the Tangle is very organic in that it also gets rid of the oligopoly centralization around miners, because there are no miners. So instead, it's completely decentralized, because every single transaction acts or has the same weight, so to speak. There is no I'm a super node and none of that is in the Tangle architecture. And so we resolve kind of fees, scalability, and centralization. And of course, when you do that, it doesn't happen overnight. So we had to introduce this element that is called the coordinator, which is a special node, temporary special node, which is kind of like training wheels. So instead of putting the kid on a bike and just hoping that it's like push it down the hill and hope that it survives, instead you put on training wheels until the network grows and can become self-sustaining. But the entire validation still happens completely at the individual level of transactions. So this coordinator cannot do any double spends. It can't reverse transactions. It can't do anything. It just issues milestones, which is equivalent to how the Bitcoin network was bootstrapped with checkpointing. Mm-hmm. But now in 2019, I keep forgetting date, but now in 2019, we have this coordicide plan. Coordicide is our name for the end of the coordinator. So, we managed to kind of solve those three main pain points of blockchain. And we did it because we came from a completely different angle. We weren't trying to make a better Bitcoin or a better Ethereum. We were just trying to figure out how can the Internet of Things actually have millions of transactions going through, data transactions and value transactions. And that is another beauty of the Tangle, is that you can actually use it as a data layer that ensures data integrity, because there is no such thing as a fee. Mm-hmm. So you can imagine like using Bitcoin during high intensity, you would have to pay like $50 for a packet of data that needed to be verified. That's not scalable. Whereas in the Tangle, that is free. And when you issue that non-zero transaction that contains data, you still validate other previous transactions. So it becomes this very self-sustaining network.
This episode of Hacker Noon is sponsored by DigitalOcean. Join a community of over 3.5 million developers learning how to build and scale high-performance web apps on the simplest cloud platform. With a flat pay-as-you-go pricing structure and monthly caps across all global data centers, DigitalOcean makes it easy to get the computer resources you need without the billing surprises you get from other cloud providers. Discover why developers love DigitalOcean and get started with a free $100 credit at do.co/hackernoon.
And you've got another intention here, because you're dealing with edge computing devices. You're dealing with devices like smartphones, as you said, IoT devices, we're now, it's interesting because I remember like a few years ago when IoT was like the big rage, and, they were talking about it at Salesforce and everything. And now here we are a few years later, and it's like, we're still just trying to kind of figure out the nuts and bolts of it. VR kind of did a similar thing where, it was really hot a couple of years ago, and now it's like, oh, wait, we actually have to program games. So IoT is kind of going through something similar where it's like, okay, yes, we have the hardware finally, but now we have to write the software for it. Can you talk a little bit about, what edge computing means to you and how that kind of changes the game here, especially when it comes to transactions?
Yeah, for sure. So I guess the best way to contrast this is to begin with what we call the internet, because that's the cloud. That is the familiar thing that everyone uses every single day and everyone is familiar with. That's the cloud infrastructure. You always have an abundance of bandwidth. So you never have to take into consideration how much data am I sending. Whereas these edge devices, which can be sensors gathering climate data, or it can be vehicles that are packed with different microcontrollers, those don't have that luxury. Even in the age of 5G, that doesn't automatically solve everything, because I don't remember the exact percentage, but the coverage on the entire surface of the globe is still 1 digit. When you think about that, and you want sensors everywhere, you want drones to be able to fly everywhere and in packages, etc. Here you need what is called edge computing, which is then called the fog, because you have the cloud and then you have the fog. And the fog, of course, permeates everything. At least that's the idea behind the terminology, which I think was coined by Cisco. So in that aspect, you need to be able to take resource constraint into consideration, that these devices have to actually balance computation and the battery consumption of that, storage of that, as well as being able to have the bandwidth. And if you have 1 million devices all trying to send data back to the cloud all at once, you end up with signal collisioning. It's just the laws of physics. You have a limited spectrum and you can't force more data through it than is physically possible. So here you need these devices to be able to interact with one another and share technological resources. So if I am a sensor and I'm gathering some weather data or whatever, and I want that processed, it's much easier for me to process that directly to my neighbor. So I send it to my neighbor, he processes it, I pay him something for it, and that then later gets relayed to the cloud. And this was kind of the thinking in the beginning, that we really need to solve this issue of pre-processing data at the fog level before it's sent back to the cloud, because a lot of these things will need like split-second decision-making. Mm-hmm. So you can't even wait for the propagation to happen because the delay will be too high. So you need this to be at the edge. And here you need, of course, the incentive, because why would I, if I'm not owned by the same entity, why would I waste my battery on your? Like, doesn't make sense. And here is where we really start thinking about this concept of the machine economy, that 10 years down the road, when there's literally hundreds of millions of these hundreds of billions actually of these devices in existence, they need a way to settle their scores between one another. And all of the data that they gather has to be secured at that location, because if you send it all the way back to the cloud, you also have the risk of man-in-the-middle attacks. Mm-hmm. And if you start thinking about like autonomous vehicles on the horizon, you really don't want those vehicles to get any kind of malicious software updates that have, you really need to verify all of this data. So that's why the edge is so important and why it's kind of considered the next paradigm. And what we as IOTA bring to the table is the data integrity and the ability for these machines to literally be prosumers and consumers in their own economy without having to go back to sign contracts for every single minute device you deploy.
And, for the listener, this is as simple as, let's say you do have a self-driving car that is automated and you drive out of range of the network. Is your car just going to shut down? Like what's going to happen? So that's, it's important that once you do leave the network, that your device works autonomously. And then once it reconnects back to the network, it has a system to do that. And that's from my understanding, that's where IOTA really steps in.
Exactly. And there's also another component to the topology of the Tangle versus blockchain here, because blockchain kind of presumes that the cloud exists everywhere, that you always have the connectivity. So from a cap theorem sense, it is very not partition tolerant, because if you end up on a partition, you end up on an orphan block and you're essentially on a fork. Whereas in the Tangle, it is partition tolerant from the cap theorem sense. So you can indeed have these intermittent disconnects and still have these local mesh nets that still verify their portion of the subtangle. And then when they join back into kind of the main tangle, that gets interwoven back in. And that's also a design decision that we had to make all the way back then when thinking about the fact that, ironically, the Internet of Things doesn't really have internet. Like the things that we call Internet of Things, like in my house here, I have connected dishwasher and even my refrigerator, but I don't consider that Internet of Things. It's kind of like, because it exists so well within the regular internet. Whereas the real Internet of Things is when you have millions of sensors all around where there is no coverage. Mm-hmm. And so they actually rely more on mesh nets than regular traditional ISP.
And I was just having this conversation with someone else recently, is the fact that our hardware that we've been carrying around in our pockets this entire time, anyone who's ever owned an iPhone, the hardware is there for mesh networking. It's there the entire time. The only reason we don't have it is because the software hasn't been written for it. And, there was, I hate to use the word collusion, but there was collusion between Apple and, the networks, AT&T, Verizon, et cetera, because they were trying to get them to subsidize the cost of the phones, and they were trying to get, smartphones into everyone's hand. And that became more of a priority than, enabling software that would basically create a new mesh network that would basically put Verizon or AT&T out of business. So, we do have these capacities and we do have these devices already in our hands. I mean, the amount of computing processing power that is in my iPhone today, I mean, the graphics capabilities, the storage, I mean, it's insane. I mean, I remember when I had an iMac with like 400 megahertz and like a 12 gig hard drive, and that was just 20 years ago. Here we are 20 years later, and I've got a supercomputer in my pocket, and we're not leveraging it. We haven't written the software to take advantage of all that processing power yet.
Yeah, and that's a very good point, because if you, I don't have the numbers in my head right now, but if you look at how much computational power something like AWS or Azure Microsoft, if you look at how much they have, it sounds impressive. And I'm not saying it isn't, but when you compare it to the idle amount of computation that exists in all the phones and all the laptops and all the desktops around the globe, it pales in comparison. So with this kind of software, you can unlock this decentralized AWS, so to speak, that also takes into account the edge. And then, of course, your laptop, when it's idle, you can actually make money from it. So it's such a huge. The same thing goes with your phone, like you just mentioned. Like, we can set up these mesh nets, so you don't have to pay the data providers insane amounts of money all the time when you don't need to. You could pay these microtransactions to someone that has like excess bandwidth and take care of it that way. And that I genuinely believe will be one of the main killer applications of crypto, that you can actually do these things without contracts, without any of the red tape that is in the way.
Yeah, no, it definitely changes the game, because it creates, consensus, and it creates systems for being able to interact and allow the machines to negotiate so that, we're not having to do all of these processes manually, or having to hack our hardware to connect to the network or whatever. It's a total game changer. So can you talk a little bit about, what your thoughts are on just crypto as a whole? Like, what's happening with the market? Obviously, we had 2017, we had this big boom. Then we've got, whatever 2018 was, and now there's 2019 where it's like, what's going to happen next?
Yeah. So I've always, given the fact that I've been there since 2012, I've seen small bubbles come and pop and so on and so forth. But of course, 2017 was staggering, because now crypto went viral. Like, literally everyone wanted to buy crypto. I was stopped on the street all the time by completely strangers, like, hey, how can I buy IOTA? And I was like, don't bother me. Like, I'm not here selling you anything. But then, of course, afterwards, I think people finally realized that a logo and a white paper that contains like 5 sentences doesn't really have a purpose to exist. And you don't need a separate token for every single thing that exists in existence. Like, because that was what we saw with the ICO boom. Like, suddenly there was a token for cannabis, you had a token for bread, you have a token for cars. Like, why do we need thousands of tokens? It just doesn't make sense. If I go to the store, I don't want to bring up a separate token for bread, for milk, for juice, for whatever. So when people started realizing, hey, this doesn't really make a lot of sense, it collapsed. Just like the dot-com bubble, when you had pets.com being worth, like, I don't remember how many millions of dollars it was worth at IPO. And it's like, we reached the same stage. And then 2018 came, and of course, as these market cycles evolve, people get depressed and lose all hope and that kind of thing. The good thing about it, at least from my personal point of view, is that it killed off all the unserious projects. The projects that were just noise, like BitConnect, like what the hell? Like these projects that were literally just noise and making the real projects look bad. Because from the outside, it's very hard to differentiate between thousands of different... everyone claims the same. We have solved something. We have something very important. Whereas now in 2019, it feels like we are finally getting to a point where most of the bad projects just died. Most of them didn't even manage to secure their funding that they had from the ICO, even though several of them raised like hundreds of millions of dollars. And of course, that was also a good reason for the recession, so to speak, because everyone tried to dump their ICO funding. And of course, that drives the price down immensely because the supply far outweighed the demand. But now in 2019, I feel like the companies, especially the companies that we speak to as the IOTA Foundation, that they have a better idea. And the man in the street, of course, they don't understand the technological components, but they understand that there's a lot of scams in crypto. So they are a bit more... they're a bit more aware of that. There are still a big problem in terms of when you look at let's say you go into CoinMarketCap and you look at the volume of some of these coins that never get used, they have no community, yet they have like $200 million 24-hour market volume. And there was one report in late 2018, December, I think it was. And then there was another one a week ago by Bitwage that kind of tried to analyze how much of the trading is wash trading, literally the exchanges faking the volume. And it was like 90% was fake. So that explains why so many of these coins that doesn't seem alive on the market. And now I think the next phase will be that gets corrected. Now that the big exchanges are taking interest, all the venture funds, the hedge funds, etc., they don't want to play that game. Like they understand finance. They're not going to pay millions of dollars for something that isn't worth anything. So when that gets corrected, I am hopeful that phase of crypto is over. And now it's really about prove what you have. Like a logo doesn't mean anything, a fancy website doesn't mean anything. Even a copy-pasted white paper like Trent did doesn't mean anything. You have to prove it in software and prove it in actual proof of concepts. And hopefully by the end of 2019, at least in the IOTA Foundation, we are aiming to have really integrated products with real companies that integrate this into their cars or into the electric grid. We have a project here in Norway, up in Trondheim, with the biggest university in Norway, and one of the biggest electricity providers that are using IOTA now in one of their smart buildings of kind of the sharing of electricity. That's what I hope will happen throughout 2019, that becomes the benchmark. If I was an investor, I want to see some actual progress.
Yeah, and it comes down to code and seeing it being implemented. And I mean, the hardest thing is actually getting users. We just have, I don't know what your user base is looking like right now, but from what I've talked to when talking to other founders and CEOs of blockchain companies, like there's a major issue of getting people to actually use a lot of these blockchain projects. So do you mind me asking, like, are you finding use cases? Are developers in the community starting to show up?
Oh yeah, like, and this is one of the brilliant things from our point of view, at least, is that we didn't go down the crazy route of saying, hey, we're going to replace the euro or the US dollar. Like that wasn't our intent. We were going for this blue ocean of the Internet of Things. And here we approached the big companies like the Bosch, the Volkswagen, these kind of companies, and started interacting with them. And through this continuous growth. A lot of these companies, like for instance, Fujitsu has this display at the Hannover Messe last year. I think they're doing another one this year. And these are big companies. Of course, it's still very early stage beta projects. They're not ready for full-time deployment, but we are seeing that ecosystem grow kind of exponentially. And that also gets the developers interested. So right now we have, together with Hackster, .io, we have this big smart city hackathon, and hundreds of people have signed up, and we keep getting those people, and those are the people we want. We want the builders, because the only way to get actual end users is to have killer applications, and no one knows exactly what those are yet. We can kind of make educated guesses, and we can create theories, etc. But at the end of the day, it has to be something that replaces, that is kind of like 10x better than what is currently being used. So we are seeing that, of course, when it comes to peer-to-peer transactions between humans. That is still very, very small in all blockchain projects, because the mentality of most people is hodl, like not spend, hodl. You don't do the same with your local currency. You don't hodl it in hopes that it will go up versus I don't hold my Norwegian kroners and hope that it'll go up against the USD or Euro. So as long as that mentality still permeates the entire space, we won't see end users using it as a currency. But in IOTA, we are focused more on the machines, and they can't use Visa, they can't use fiat. So that's where we are focusing most of our resources to really get that going.
And could you maybe kind of explain the difference between IOTA's approach and Ethereum's approach? Because I feel like Ethereum definitely, compared to most of the projects that I've seen, there's definitely a pretty significant development community there. How is your approach different than theirs?
Yeah, so Ethereum, I remember Ethereum very well early on, because we hung around the same kind of circles. We met with the same people, we met the team, and we even in the beginning, when IOTA had begun a year after Ethereum, we were even considering building kind of a bridge between the two, but it was just impossible at the time due to the gas expenditure in order to do such a thing. But what I really commend Ethereum for doing is building that development community. And with Solidity, even though it was very flawed in the beginning, like everything is, they had something that was really easy to deploy and start experimenting with. And if you are a hackster, if you want to build something, you go where it's easy to build. Of course, I still don't think there's a single decentralized application on Ethereum that actually has users beside perhaps a few gambling dApps. That's pretty much like
couple games, yeah.
And the crypto kittens, of course, can't forget them.
Yeah, but there's been a couple games. I don't know of much beyond that. I've seen smart contracts, of course, being used in certain situations. We just talked to Harbor, and I'm pretty sure they're using Ethereum smart contracts. Hope that's correct. But I've seen some use cases where people are using smart contracts on the Ethereum platform. It's definitely a viable use case, but I haven't seen anything that was mass adopted beyond CryptoKitties, and even that kind of deflated.
Yeah, and the thing is, Ethereum, for all the good that they have done for the space and the adoption of real developers that come into it, the problem is that Ethereum still sits on a one-dimensional blockchain. So when CryptoKittens happened, you kind of saw the limitation of the Ethereum platform, because the CryptoKittens completely stole the entire network. It consumed the entire network. And I mean, you can't build a world computer when a meme can kill it, or halt it, I should say. So the difference between our approach and Ethereum's approach, I tend to liken it with IOTA's layer 1 protocol, the transactional settlements and data transactions. That is the one thing we optimized. So we didn't build smart contracts into that layer. We didn't build smart contracts into the Tangle itself. Because if you try to put everything into one, you end up with a Swiss Army knife. It has a knife, it has a tiny scissor thingy, and it has those components, but all of them suck because you have to make sacrifices in order to put everything in. Whereas IOTA, we wanted to create the absolute best optimized, decentralized, permissionless ledger for settlements and data transactions. And then smart contracts come on top of that, like a layer 2 solution. So that's a very different design philosophy. And if you look at Ethereum, they have to kind of do the reverse. They are looking for Plasma in order to kind of solve the transactional settlement layer that they can't do on the ledger. So now they need these payment channels. And then you need the hubs, and you need to solve all of those very hard routing problems. And it doesn't really live up to the truly decentralized, permissionless, fungible cryptocurrency.
Well, so, now you've got to run Casper if you want to do proof of stake, and now you've got to, they've got side chains and all these other things that they're trying to figure out to solve a lot of the problems that it sounds like IOTA's already worked on. Because the way I see it is like there's kind of the traditional way of how we have built technology where, it was always like, oh, if your website's growing, throw, more CPU and memory at it and just keep throwing more compute at it. And they didn't build resiliency into the network. And in IOTA's case, it sounds like the more people you add to the network, the more resilient it becomes, which is the opposite of what happens with current kind of centralized systems where, the more people who show up, the more your hosting bill is.
Exactly. And the other thing that touches upon is also the fact that Ethereum is always at the mercy of the miners. Like if they are to introduce something that brings the transactional fees down significantly, they have to convince the miners that, by the way, now you're going to get paid way less. And if they disagree, then they don't adopt that into the software. So they're always at the mercy of these people that only care about profits. And it's such a hard political game to play because it's not that many entities either. Like we are told this vision of blockchain that everyone can fire up a node and do the mining, but that's not reality. Like the reality is that there's like a handful of big mining pools that are kind of like an oligopoly that controls the network. And if you can't convince them of your new fork, so to speak, you have to make compromises. And this is one of the things I'm so grateful that we don't even have to think about in IOTA. Like if we have a better optimized algorithm or whatever, we introduce it. Of course, the nodes can reject it, but there is no incentive for them to reject it because they don't lose any kind of profitability from mining because mining doesn't even exist as a concept. So yeah, I'm very happy that we didn't go that route. But the reason we didn't is because we had already done blockchain. We did proof of stake. We did all of these things back in 2012, 13. So we knew that if we were going to tackle this, we had to tackle it from scratch and do completely opposite. Just turn it on its head and Tangle came out.
And I kind of see IOTA as kind of a post-blockchain solution, kind of similar to a holochain or some of these others that are starting to emerge as well. Because it's like you said, we've moved past the blockchain because there's so many different limitations and kind of initial flaws in the initial concept of how blockchains worked. And it's not a bad thing. I think it's a good thing to have an evolution of that technology and kind of figure out how to solve these problems so that it becomes a viable solution. Because at the end of the day, minus the libertarian side of it, we need network resiliency and we need to solve this scalability challenge for the app developers as well. Because I can tell you as a former startup founder myself, like I was in a situation where the software that my company had created, we had millions of downloads of our software, and it became a huge scalability nightmare. It was an open source web-based project. It was like WordPress themes and plugins and that kind of stuff. But, I can only imagine what an app developer today goes through when they, get a app that goes viral in the App Store and millions upon millions of people download it. And all of a sudden they're looking at their AWS bill going, wait a second, I'm only charging $1 for this, or,
Exactly. And then you have to increase the price and suddenly you lose the customers and you have this constant balancing game. That's the hard part about being an entrepreneur in that space. And for app developers, it's very similar because you have to like what is the profit model? Like what is my incentive here if I have to pay all these mining fees and these gas fees and so on and so forth? And of course, you do have some fees in every service. Like when we deploy smart contracts in the future, there will inevitably be some kind of fee for that, but there shouldn't be a fee for the transaction itself. Mm-hmm. That is what we see, and I agree with you 100% that technology should evolve. Like Satoshi Nakamoto stood on the shoulders of the people that created BitTorrent, etc., drew inspiration from these things, and came up with a prototype, Bitcoin. And then, for some reason, everyone just decided, oh yeah, this is the final version. Like now, innovation, no progress, no. And it's because there was this speculative component. If Bitcoin was just for data integrity, for instance, you would not have that. But because all of the economic incentives involved is maximalism, you end up with stagnant software. There is no updates. Whereas we had the ability to stand on the shoulders of Satoshi Nakamoto, and of course, whenever you stand on the shoulders of someone, you see a little bit further. So you can always be better. And I think that's the number one thing for all technology. You should never say this is perfect, we've solved it, now we just go home. It's always, especially open source software, it should always be scrutinized and optimized.
Yeah. Well, awesome. So I got to ask, when is some time in your life that you've had to hack something?
Yeah, so actually two things come to mind. So when I was 11 years old, me and my cousin, my cousin was a really brilliant guy. He was really into the very early tech. And I remember we were sitting in his room. I was sleeping over there, and I didn't understand half of it at the time, but and suddenly the day after we get a call from it's called PST here in Norway. It's like the main police. I don't know what the equivalent is, probably like the CIA or something in the United States.
FBI or something like that. Yeah.
Something like high up, and we were just little kids, and it was like, oh shit, like this is pretty crazy. But it was just pure curiosity, and at that age, you just want to push the limit. You want to see how far you can get. We didn't get in trouble. I remember my cousin; he wrote like this very articulate letter and apologized as a 12-year-old. And it's weird that he didn't actually get a job offer from that.
So what exactly was the hack? What were they upset about?
So I think he just breached their databases and just changed. Very basic thing. Like I don't think it posed any kind of threat or anything. It was just poking around for the sake of poking around. The other thing that just came to my mind was I have this again IoT blinds, and I lost the controller, and I didn't want to buy new controllers. I just figured out kind of the frequency of the Bluetooth so I just tweaked it, and now I have this homemade controller. I didn't have to waste money on buying a new one. So yeah, I think that kind of mentality is important, because at the end of the day, it's just problem solving and solving puzzles.
Awesome.
So, yeah.
Do you have any final thoughts before we wrap up?
No. My final thoughts is that, yeah, if I can like speak to the cryptocurrency enthusiasts and the crypto or DLT enthusiasts, I hope that 2019 becomes a year where these projects no longer huddle in their own like tiny spot and kind of fight each other with maximalism. Instead, I hope that we can start to consolidate around some of the standards and try to actually get something that's easy for developers to use, rather than just like, this is mine, fuck yours. Like, I really want to get to the point where instead of new projects spawning up all over the place, let's instead consolidate around the ones that have momentum, and then you can build solutions on top of that and make money that way instead of just firing up a new ICO. So yeah, that's pretty much my sentiment and hope for 2019, because it's so imperative for this space to mature and be used in the real world.
No, absolutely. It's time for crypto to grow up a little bit, and at the end of the day, may the best protocol win.
Exactly, it's Darwinism. It's just Darwinism. The best will win, and it's open source. Everyone is free to use it if it's permissionless ledger. So there's nothing to be worried about. There's no reason for this tribalism. Yeah.
And where can people find you?
Yeah, so of course you can find me if you want to check out the IOTA project, you can just go to iota.org. If you want to follow my Twitter, then it's twitter.com/David, and then it's Sønstebø, which is probably not easy for everyone, but you can probably just Google my name based on the video you're watching, and you will find me.
And are you going to be speaking soon, or one of your colleagues are going to be speaking at a blockchain event soon, I believe in Paris?
Yeah, we have events all over the place all the time. I know that I think it's on the 4th of April. We are doing this announcement with, I think it's 100 other entities, together with the European Commission, setting up this new consortium. So that will be interesting. Look out for that. Again, the entire goal there is to bring entities together. Let's get some stuff going with the actual real world. Instead of just fighting them all the time, let's Trojan horse instead and get in there and convince them of the superiority of the technology and the importance of the technology. So other than that, we have speaking engagements all over the place all the time. So, and if you want to attend a meetup, we have a list, I think, on the website where you can see the next meetups. Yeah.
Awesome. Well, thank you for coming on the show. It's been a pleasure.
Yeah, likewise. Thanks for having me.
This concludes another episode of the Hacker Noon podcast. I'm your host, Trent Lipinski. Please don't forget to subscribe to us on iTunes and YouTube and follow us on social media. You can also find us at hackernoon.com and podcast.hackernoon.com for more episodes. Thank you for listening.